All right, let's go ahead and finish up our notes from section 2.8. This is part 2, okay? This is also on page 42 of your packet. So one method for finding the inverse function is to reverse x and y. So anytime you see this word inverse, remember that we're swapping x and y. So to find the inverse, remember that f of x is really y. So if we're going to find the inverse, this y is now x, and every time we see x, we swap it with y. So we just rewrite it the way we see it, but we swap x and y. Then our second part is we're going to isolate the y value. Okay, so we're going to subtract 3. I get x minus 3 equals y plus 2 to the third power. Now I'm going to get rid of that power of 3 by taking the third root. This will cancel. Take it of the other side. And I'm left with y plus 2 equals the third root of x minus 3. Last step, subtract the 2. And I get y equals the third root of x minus 3, all minus 2. Last thing you're going to do is you're going to rename your y as the inverse of f of x. So we say, hey, inverse of f of x equals the third root of x minus 3, all minus 2. Okay, you can also, the domain of the function can be restricted to make the function invertible. So this here, if I look at it, it looks something like this. But remember, we said it's not invertible if there's a maximum or minimum. So if we want to restrict it, I could just say, hey, let's just look at this part. So if I know this, this point here is at 0, 2, this tells me that I know, hey, then x can only be greater than or equal to 0 if I want to restrict the function. So if I want to find the inverse, we say, okay, we can find the inverse, but remember, this is going to be the domain of the inverse. If that's true, or the domain of the function. If that's true, for f of x, the domain is from 0 to infinity. If that's true, then our inverse function has a domain of whatever the range is, but the range is the same as our domain of f of x, which is going to be 0, infinity. So now let's solve the rest. So we know that this is y, so we're going to rename it x. 1/2 y squared plus 2, as long as x is greater than or equal to 0. Subtract the 2. We get x minus 2 equals 1/2 y squared. Multiply both sides by 2 to get rid of that 1/2. And then I've got y squared equals 2 times x minus 2. Take the square root of both sides. Remember, whenever you take a square root, it's got to be plus or minus. But because we've restricted the domain and we're going greater than, we're only going to keep the positive side. We're going to not use the negative side. So we know y equals the positive square root of 2 times x minus 2. So this tells me that the inverse function is the positive root of 2 times x minus 2. This also tells me that the domain for this function tells me, hey, I just can't have what's inside the root to be negative. So I know 2 times x minus 2 has to be greater than or equal to 0. Divide both sides by 2, we just get x minus 2 is greater than or equal to 0, so we get x is greater than or equal to 2. So therefore, the domain of this starts at 2, and it goes to infinity. All right, so if we're looking at this, just a little bit of practice, find the inverse function along with the domain and range. One of the best ways to start this is just looking for the domain of f first. Remember, there's a red flag here. This tells me the root cannot be negative. So I know x minus 3 has to be greater than or equal to 0. So therefore, x has to be greater than or equal to 3. So therefore, its domain has to start at 3 and go to infinity. That also tells me that this is the range of the inverse. So now let's go ahead and find the inverse. So if this is x equals the root of y minus 3 plus 2, let's go ahead and get y by itself, subtract the 2. We get x minus 2 equals the root of y minus 3. Square both sides to get rid of the root. And we get y minus 3 equals x minus 2 quantity squared. And then we're going to add the 3 to get the y by itself. So this y is actually the inverse of f of x. and we get x minus 2 squared plus 3. If that's true, we're looking here for its domain. There is no red flags for the domain. So the domain here is from negative infinity to infinity. All right, let's look for number 6. Okay, let's look at number 6. It says, here's our function. Let's look for the domain. Remember, there is a red flag here. There's a denominator with an x in it. So the denominator, which is x plus 6, just cannot equal 0. So that means x cannot equal 6. Therefore, it can be from negative infinity to 6 and from 6 to infinity. Let's find our inverse now. To find our inverse, we're going to rename this as x equals 3 over y plus 6. Let's isolate that y. So we're going to, because the y is in the denominator right now, we have to multiply it so it's not in the denominator, which means we're going to multiply it to both sides. So we end up with x times y plus 6 equals 3. Next step, to get y by itself, we're going to divide both sides by x. So we get y plus 6 equals 3 over x, and subtract the 6. So y is actually the inverse x of 3 over x minus 6. So because we found the domain here, it's also the range. Oops. And if I look here, the domain of this, we do have a red flag. We know x cannot equal 0, so we know it goes from negative infinity up to 0, and then again from 0 to infinity. Okay, for number 7, we're going to look for our domain here. Our domain, we do have a red flag here. It's a denominator with a variable. So that tells me my denominator, which is x plus 4, has to be not equal to 0. So that means, hey, x just cannot be negative 4. So if x can't be negative 4, it can be negative infinity to negative 4, and from negative 4 to infinity, which tells me that's also the range of the inverse. We can just get that out of the way. And now let's find the inverse, okay? So again, let's find the inverse. This tells me this is x. 2, instead of x, we use y. X, which is now y plus 4. Okay, so again, we're trying to get x, or excuse me, y by itself. We're going to multiply it out of the denominator. Multiply y plus 4 here. So we get x times y plus 4 equals 2y minus 3. These cancel. We're still trying to get y by itself. So what you're going to do now is we're going to distribute. So this is xy plus 4x equals 2y minus 3. So since we're trying to get y by itself, we're going to get y's on the same side of the equation. So let's subtract this 2y over. And I only want y's on that side, so I'm going to subtract the 4x over here. So I'm left with xy minus 2y equals negative 3 minus 4 times y. Oh, sorry, this is an x, pardon. And now I'm going to factor out that y to get it by itself. So this both have y. So this is really y times x minus 2 equals negative 3 minus 4x. Get y by itself by dividing by x minus 2. Okay, so now this is our inverse function, which is negative 3 minus 4x all over x minus 2. Whew. To find our domain of it, we're going to look for red flags, which is a denominator of a variable. So we know x minus 2 just cannot be 0. So that means x cannot be positive 2. So if x cannot be positive 2, we know it can be from negative infinity to 2 and from 2 to infinity. Okay, so here's the last little part of our notes, the composition of f and the inverse of f. So if we know if they're the composition of those, it is the identity function. We've talked about this before. It's just x. So if I can take the composition of them, I can prove that they are inverses as long as their composition equals x. So how do I prove that f of x and g of x are inverses? I need to see that f of g of x equals x, and that g of f of x also equals x. So we're just going to take the composition of both, okay? So here we go. To find f, we're going to use this as the skeleton here. So we say 2 over x plus 3, where g of x is our inside function, so 2 over x minus 3. And then now we're just going to simplify what's in. We get 2 over x minus 3 plus 3. These cancel. This becomes 2 over x. Dividing by a fraction is a reciprocal, so 2 times x over 2. The 2's cancel. And looky there, we get x. So now we just have to check it for g of f of x. So g is going to be our new skeleton. So g of f of x. G is a skeleton, so it's 2 over x minus 3. Inside that function is going to be f of x, which is 2 over x plus 3. So now let's simplify it. So we get 2 over 2 divided by x plus 3 minus 3. Remember, dividing by a fraction is multiplying by the reciprocal, so this is really 2 times x plus 3 over 2, all minus 3. These are going to cancel out the 2's. We're left with x plus 3 minus 3. These also cancel, so we get x. So are they inverses of each other? Yes, because their compositions are both x. That's it for now. See you in class.